Hi class, welcome to topic 2 DQ2. In this DQ, we are going to look at another linear example. This example is going to be similar to the other linear example we looked at. The main difference is that the linear example here, the original data we start with is not going to be perfectly linear. So the data we're starting with is going to be close to linear. We're going to find a best fit line for it, and we're going to use that to predict values and answer some questions. All right, so as always, start by putting your name in the blue cell. Once you put your name in, you should see your data generate. The data we're starting with is the stopping distance data. We have the speed, meters per second, and the distance m. And if you go up into the steps, they'll tell you which one represents which. We're using the distance m as the y values and the speed, meter per second, as the x values. So in our table, the speed is our x values and the distance m is our y values. All right, so we are going to start by finding the slope and intercept. We're going to find this the same way we did in the other DQ. We're going to use the functions intercept and slope. We're starting with the intercept this time, so we want to start with our equal sign, type out that word intercept, and then open your parenthesis. After you open your parenthesis, you want to highlight the y values first, type a comma, highlight the x values, close the parentheses, and hit enter. So the y values are the distance. So highlight your distance after that parenthesis, type a comma, and then go highlight the speeds. And then close your parenthesis and hit enter. Repeat the same process for slope. Use the word slope this time. So type your equal sign, type out the word slope, open your parenthesis, highlight the distance first because the y values go first, type a comma, highlight the speed second because x values go second, close your parenthesis, and hit enter. Okay, so we are looking at a y-intercept of negative 5.705 and a slope of 1.42. So let's go ahead and write out the equation. When we write out the equation, let's use 2 decimal places. When we write out the equation, we're going to follow slope-intercept form of the line because this is a line. We found the approximate y-intercept and the approximate slope for this data. Again, it's not perfectly linear, so we're finding approximates. They're not perfect. And we're going to write out the equation in slope-intercept form. So our slope-intercept form, I'll write it below. Ooh, that's protected. I can't write it below. It is y equals mx plus b. So y equals slope times x plus y-intercept. So we type it in the cell. We'll do y equals, and then our slope. Go ahead and just manually type in the slope you get. So my slope was 1.42. X follows after the slope, and then your y-intercept. Our y-intercept is negative, so I'll do the minus for the negative, and then 5.71 when I round it. So my equation is y equals 1.42x minus 5.71. That's following y equals mx plus b. 1.42 is my slope m. Negative 5.71 is my rounded y-intercept b. Okay. Now that we know our slope and our intercept, we can graph the line and we can find predicted values. These values are predicted. They're going to be approximates again because we are finding an approximate slope and y-intercept. These are not perfect because our data is not perfectly linear, and we'll see that when we make the graph. Okay, so like before on the previous DQ, we are following that formula y equals mx plus b. We are starting with the equal sign. Again, I will model the first formula in this first cell, and then after that, we're going to use the autofill on the rest of them. So the formula we are following is equal sign slope times the x value. Use the x value sitting next to you. So we are predicting the first one for 3. So slope times that 3, and then plus the y-intercept. So I'd click on my y-intercept. So then my formula would be equals B24 times E15 plus B23. Equal sign slope times the x value you're on plus the y-intercept. And then hit enter. All right, let's do it with the autofill so we don't have to type in each formula individually. Slope and intercept are going to stay the same. So when we do the autofill, we'll click on the slope and y-intercept just like we did before. When we do the x values, We want all of these x values to be included in the formula. So when we do the x values, we're going to make sure that we highlight all of them, and that will do the autofill for us. So start in the first cell you want to type in, start with that equal sign, grab that slope and click on it. And then we're going to times, and we're going to times by all of the x values in our table. So I'm going to start with the first one we're on, and I'm going to click, hold, and drag and highlight all of those x values left in my table. That should type in a range into your formula. After that range, type your plus, and then click on the intercept, and then hit enter. And Excel should fill all those values in for you. After you finish your formula, make sure you follow your formatting here. Format everything to 2 decimal places. Now we're going to make the chart. Chart is where it could start to be a little bit different from before, because now we're looking at data that is not perfectly linear. So when we go to make our scatter plot this time, we cannot get a smooth line by choosing from our chart options. We're going to have to insert a scatter plot. Okay, so we are on the steps continued. We want to insert a scatter plot for the stopping distance data. That's the very original data. We want to add a trend line, a linear trend line, and extend it to include all of the predicted values, and then use the scatter plot to answer the questions below. So we have some questions below where we're putting the scatter plot. Okay, so first step, we need to make a scatter plot of the stopping distance. The stopping distance was the very original data, so it's going to be what we started with. This is what we're going to make a scatter plot of. So I'm going to highlight the data I want to make the scatter plot of. I'm going to go to Insert. I'm going to find my charts. I'm going to find that scatter plot, which is in the middle bottom. It's all the dots. And this time I want to choose the first one. Do not choose the one with the lines because it's not a smooth line. We don't want to see that. We want to see the dots for right now, and then we'll insert the trend line. So I'll create my chart. I'm going to size it down a bit and move it to fit into this box. Make sure your chart has an appropriate title, and then make sure you add some labels. So I'm going to go ahead and do that with my chart using the add chart element. I'm going to add some axes labels and change up my title. Okay, so here I have my chart. I added in some axes labels. I changed my title to represent the title of the table. The title can be anything besides chart title. And then make sure you label the axes appropriately. Remember, our speed is representing the x-axis, which is the horizontal axis, and our distance is representing the y-axis, the up and down axis. And remember, you can add axes by clicking on your chart, going to Chart Design, Add Chart Element, Axes Titles. You can pick the one you want. They'll appear as text boxes, and then you can type in them. Okay, after you've got your chart, you've got your labels, now we need to include a trend line. So we're going to go to that Add Chart element again. We want to go down to Trend Line, and we want to pick Linear. This is going to give you an automatic trend line on your chart, and it's going to span through your points. So our stopping distance from the X values is going from 6 to 21. So our trend line is spanning from 6 to 21 as the speed as those X values. We need to extend it to include all of the predicted values. The predicted values are going from 3 to 33. So we need to adjust the endpoints from 6 to 21. We want to bump it out to 3 and then to 33. So we need to change the format of the trend line. So go back to your chart. You're going to right click on that trend line and choose Format Trend Line. A window is going to appear. Okay, so I want to see my tables right now. I'm going to pay attention to my tables. In this window, you're going to scroll down until you see the forecast area. We care about the forwards and the backwards. So the backwards part is the left side of the line, the smaller points. So when we're talking about the backwards, we're talking about taking this 6 and pushing it out to 3. Our line is sitting at 6 right now, and we want to bump it out to 3. So we need to push it back 3 units to get it from 6 to 3. So for the backwards, I would type 3 in there. And then when I click out of that, if you can see your chart, you're going to see it extend out to 3 on the x-axis for that left endpoint. Okay, so now let's do the forward. So for the forward, I'm starting at 21. My stopping distance ends at 21. So right now my endpoint's at 21. If I scroll over on my graph, you can see the end of the line on my graph is sitting at 21. We need to bump this out to 33. So we need to push it from 21 to 33. So to get from 21 to 33, we need to push it out 12 units. If I add 12 to 21, I get 33. So I'm pushing it out 12 units. So for forward, I'm going to push it 12. And then once I click out of that box, go look at my chart. You can see now my line has extended to between 30 and 35. Now it's sitting about at 33, and that's what we want. That's exactly what we want right there. So now we can see it's going from 3 to 33. Okay, well, we still have this window open. Let's go ahead and display the equation on the chart just because it's neat to see and it can help double check our work. So I'm going to check mark that box, display equation on chart, and then I can close out of this. So when that equation appears, you can double check it with the equation you wrote. So Excel will generate the equation y equals 1.4246x minus 5.7052. So ours is rounded a bit more, but that is the same equation we got. So that is a way to double check your work if you are making lines in Excel. Okay, so let's answer questions about our chart and then we'll be done with this DQ. Okay, so first question. Use the graph to approximate the stopping distance at a speed of 28.5 meters per second. Okay, so let's start by finding my speed. So I'm at 28.5 meters per second. Speed is down on my x-axis, so I'm sitting here-ish, about 28.5. I'm going to go up from 28.5. I'm going to find my line. And then I'm going to go over and find the appropriate stopping distance. So I'm going to track this over. I'm going to try to be as straight as possible, to be as exact as possible. And I'm sitting somewhere between 30 and 35. If I look at it, I'm going to say maybe it's about halfway through, maybe sitting on the larger side. So let's go ahead and put it at 33 for an approximation. So then using my graph to approximate where about 28.5 meters per second is, I'm going to say it's a distance of 30 meters. A distance of 33 meters. I apologize if I said 30 before. We're looking at 33 because we're between 30 and 35. We're saying we're close to 35. So we're looking at 33 meters. Okay, so the next question to answer, let me erase my drawings. Give an interpretation of the slope and intercept. Do both make sense? So go back to your slope, go back to your intercept, and try to determine what they mean and do they make sense. The slope is representing a rate. So the slope represents how the speed increases compared to the distance. So how does the speed of the car as you're going faster, how does that affect your stopping distance? The intercept is your starting point. So at a speed of 0, your intercept represents the distance you need to stop at a speed of 0. So give an interpretation of the slope and then give an interpretation of why you think that y-intercept doesn't make sense. That y-intercept should be a distance and it's negative. So why do you think it is negative? That completes the DQ. Let me know if you have any questions.